I don't know, would it? Not yet. Okay, thank you. Good point. All right. But hope I'm not going to repeat all of that. So I think you all are here. I'll record the lecture. All right. So welcome everyone to Introduction to Real-Time Robotics. My name is Saida Zia Fard. I'm a senior lecturer in the Electrical Engineering Department, Computer Engineering, ECE. I just got promoted. So you can call me by my first name, Saida, or Dr. Z. Either way works for me. And so this class is composed of 4 different groups: ECE undergrads, ME undergrad, MAE undergrads, ECE graduate student, and MA graduate student. So we have a good different backgrounds. So that's the problem we have to keep sharing. So sometimes if you're an undergraduate student, if you're a graduate student and some of the material seems repetitive for you, you just have to be patient because we have the other group that might not have seen or heard these. All right. If you are undergraduate student and sometimes I talk about topics that doesn't seem familiar, you're like, okay, what is going on? Feel free to ask because I might forget at points that you might not have the background, especially sometimes the ME side, MAE side, sometimes the ECE side. You might not have the background coming to this class, okay? So feel free to tell me. If you communicate with me well, you're going to enjoy this class. I'm going to enjoy this class. All right, let's try this one more time. I think if I don't touch this, it turns off. I have to figure that out. How many of you already looked over Carmen page? Cool. Don't be shy. All right, so you want to go and check the Carmen page. We're gonna look at it today, but if you are a class with me, you know, Carmen is my main way of giving you the material, sending you messages, all the assignment, everything has due date. You'll find information in different places. All right, so take good use of that. Don't be waiting for me or being confused. I don't know where lecture 4 is. It's supposed to be up there in different places. If you couldn't find, you have to find. Also, if a link is broken, there's a chance, tell me. Sometimes things doesn't work, even though I upload them, it might not work. So be very quick in communicating with me or with Brett. Either way works. We are in good communicating. All right. So I have a PhD and master in mechanical engineering. Yay, mechanical engineers, I'm on your side. But I really do love the electrical and computer side of STEM as well. I'm not very well versed on those, but I'm trying to learn more. I worked on control and robotic, underwater robotics during my PhD. I work in industry, in oil and gas for 6 years. 2 years of that was in Iran, that's where I'm from, and 4 years was in China. Then I decided to come to US to change gears, to study something differently, and then I ended up studying underwater vehicles, which is pretty cool. Moved to Columbus because my husband found a job. Then here, there's this great Ohio State, just found this job and I stayed. So just quickly about me, if you have any interest in robotic control, even engineering education, you can come to me, we can do research on the side. Parth here is the president of the underwater robotic team, which I'm the advisor of that team. So if you want to, especially if you are a grad student, or if you are undergrad that you're staying, you're not graduating right away, you can start working with them. They have really great short projects that can help you, because all I say here is kind of theory still, even though we will be coding a lot, but it will be for a small project. They have an actual vehicle, long-term goal that you can contribute. So feel free to talk to him after the class. I should probably post something on the page as well. All right. On this discussion board, one of your assignment is to introduce yourself. So usually if the class is small, I'll ask you to introduce after my introduction, but if we do that, it will take forever, right? And you probably won't remember. So take good use of the discussion board, introduce yourself, make sure you have a good headshot so everybody can see you, because you're wearing masks, you can't really see each other's faces, and share your interests academically and also personal. So here you are to find friends, study buddies. You might be in this class with someone that you're also in other classes. It's good to find those people, right? And I usually browse and see who is who and just remind myself that this is again a large classroom. Make sure to mention if you are a graduate student or undergrad, what's your major, so kind of help each other. And since we are going to do some of our coding assignments in teams, I'm going to group up undergrads, but from ME, MAE, and like ECE together, and then graduates also together. So it's good that you can find those people before I put you with someone that you don't know. All right. So try to be active. I didn't make it like to answer discussion polls like I did during COVID, because I know everybody hates that, because you have to go like, oh, nice to meet you, to get 5 points. So I'm just putting it on your shoulder. That's your responsibility to get to know each other. Cool. All right. So who knows the difference between robot and automation, or is there a difference? What is a robot? What is something that you can say is automated? Name a robot that you see maybe in your everyday life. Right? Yes, that's definitely a robot. So think about other things. Did you have? Who has Roomba or had at some point? Also can. Okay. Roomba could count as a robot. So now think about your washing machine. Is that a robot? Could be. No. Why? No. Okay, so a robot is a device that is reprogrammable, programmable, and reprogrammable. All right, and it's designed to do something, but it doesn't need the human as part of its task. If you think about washing machine, it's programmed, but you still need the human to turn it on or change the functions. What do you want? It's a robot. If you put your clothes in there, close the door, and it knows what to do and give you the final product. Make sense? So the idea is not like, I'm not trying to, but anything that you can program. So it could come to small 5-minute autonomous. So you have competition, 30-second, 1 minute working autonomously, right? So there's a task. The robot can understand and decide what to do. You already wrote the program. You can reprogram it. Okay, you can write something else to do different tasks. So we will call that robot. Now in this class, so there are different robots, right? We have some robots, we have vehicles, we have industrial robots, helicopters, underwater vehicles. In this class, we're going to focus on manipulator arm. So now you can put the robotic arm in everything. So you have it in surgery, right? You can put on a car, autonomous car that can perform something. You can send it to Mars, pick the rocks for you. So we're gonna basically study that part. So if you came to this class with the intention of learning about autonomous vehicles, like cars, you're gonna be disappointed because we will only discuss when we are around control and trajectory, but not much in fact. This is a real beginner, well, introduction class, not beginner, because a lot of things are high level. So kind of I wanted to talk to you about, you might not be in the right classroom, okay? If you already know kinematics, dynamics, control, you know how to do path planning, and you're here to maybe do some sensor fusion, vision, or AI, you're not going to get to any of those. So if you have other courses that you're interested in, and you can swap, you are divided between which one to go, I would suggest to go with that, because this is going to be useless for you. But if you are here for a minor, then either way you have to stay here. So even if you know you have all the knowledge, you just have to suffer through this class. But there will be, I think, learning for everyone here, but the amount of learning might not be equal to the amount of money you paid or the time that you spent. I'm just being upfront. All right. I've seen this in multi-grad because they come with a lot of information, and the course name is very fancy, Introduction to Real-Time Robotics. But you won't do a lot of real-time really in this class. We are doing a lot of fundamentals. What's the math? How things work? Like we get the equations. You can write the code, plug in, and things move, right? Then later on, maybe you go to someone's research lab, they have a robotic arm, you already know how it works. It just needs to be programmed and perform a task, right? So I just, because you still have time to drop the class without penalty, so I just wanted to tell you what you're gonna get. Now, we are going to basically cover almost all of those, at least like scratch the surface. So giving you some guidelines. Hey, if you want to do path planning, these are the methods. We're gonna go over the path planning methods, give you the equation, give you the code, but maybe we don't have enough time to do examples, too many of them. Maybe we'll be one or two. All right, so you will get exposed to most of the common methods, but you will not be working on projects. So I just wanted this to be clear. Now, what do we mean when we say real time? I explain the robotics part, right? So you have a device, you can program, reprogram, does tasks without you being involved. You already did everything. Now, the course says real time. What does that mean? What does it mean to be real time? Think about it. Yes. You can do what? You get actively input from the sensor. That's one way of being real time. For example, you have a camera on the robot, you're getting the vision data, right? And then you have an algorithm already that uses that data continuously to perform a task. What else? Good answer. Yes. Okay, I want someone to explain that. So he says there is no set motion. What does that mean? Or if you have another example of what does real time mean, you can. Or feel free to type in the, if you don't want to talk about it. Parth, what do you think real time is? So what is real time? Like right now, next minute, this is real time, right? I have to keep pushing this thing. So it's real time, but not. So let's say when you are modeling a robot, your robot say is at some home condition, home state. You don't even know what a state robot is. You have a bunch of equations. You know that your robot has 4 links, 5 servos, joints, and the center of gravity is here. You have all the equations. You program that. You model your robot, right? Now, you can define your initial condition to be anything, your home position. Your task could be anything, right? Like go grab that thing. So this 3 joint have to go 45 degrees. The grabber has to go like 360, not 360, 180, right? To grab the thing. Now, can I change this parameter to do something else with the same code? So I have the model of the robot. The home position was this. Well, and the task was that. Now, the same robot, this here. Can I change the parameter to go get this and just throw it at Oscar? Yes. So this is real time. You could change the parameter. So you didn't touch your robot. You wrote the model, right? Everything is done. But can I say like throw? So I have to give it maybe some velocity and acceleration, right? Versus a task that goes straight down. So I'm also changing the variables in the joints, like velocity. So you can change that while I'm performing. I was gonna give to Oscar, I said, yeah, never mind. So I'm changing it while it's doing. That's also real time. So when you're doing our projects, when you write the code, you model different robotic arms, you write it for a default variable. You always ask your user for input that you can change those. I'll ask you to design a GUI. It's very easy to plug those numbers in. Those are real time. Because a lot of you think real time maybe is when you use ROS. You're there, everything is really real time. You're moving forward because you have sensors. You don't have access to anything hands-on here. You have to simulate everything which will happen in MATLAB, right? But so we don't have access to sensory data. Either we have to create a table of some sort of data, right? Or we just model a path, go on a circular path, for example. So we write that, and then I say, okay, now I go on a, I don't know, maze path. So that is the sense of real time that we will be using, but we will not be using any sensor. So again, if this is not something you're interested, I want to be upfront with you. I tried to get me and ME advisor to get a lab for this course, but we were not successful because it needs a lot of money. So when you get a job, please donate for robotic lab. All right. But for now, everything is going to be simulation. All right. And not in Rust, in MATLAB. Okay, so topics that we will discuss in this course is kinematic, forward and inverse, dynamic, motion control. We'll talk about actuation, gearing, how it works, and we will touch trajectory and motion planning. So the list is based on the amount of time I spent on the topic. So a lot of like the beginning will be, well, I didn't put the math and the fundamentals, but we're going to spend some time on those. But then thematic and dynamic, controllers, actuation, and then we will discuss a few of the trajectory planning. All right. This might sound boring, but I usually get at the end of the course, oh, we thought this course was going to be so cool. It's just so difficult because the expectation is probably not right. So we won't talk about we will talk about mechanical components, but we will not use them because we don't have any hands-on. And same for sensing, vision, and communication or decision making. We try to include some topics, you know, but it will be just me introducing them to you, or we can all watch a video together. That will be all of it. All right. I'll talk about this. All right. If you looked at the syllabus, you already know how this course works. If you had classes with me, you also know how I work. For those of you that don't, class participation is very important to me because I think a lot of learning happens in the class. And I want you to evaluate yourself right here before you leave. Sometimes the class participation deadline will be by the midnight because you might need to do something that there's not enough time in the classroom. So watch out for the deadlines for class participation is usually in the classroom or by midnight. So I know some of you might work or have plans, so try to plan accordingly for those. It's 15% of your grade. Then you have homework, programming, exam 1, 2, and final project. Those are very standard. Right? You can find everything on Carmen, and you can see all the due dates. So I want everyone to don't assume anything. Oh, we thought it's gonna be due by class. No, you have to check everything. This course again is about fundamentals. That being said, I want you to do all the calculations first by hand. Then you can verify a MATLAB or your calculator. That part is fine because in real life we are going to use those devices, right? But the process of critical thinking and thinking how are we going to solve this, the problem solving happens when you don't have those aids. Once you figure that out, once you build those neural networks, you know, once all those neurons are connected, then yes, feel free to use software. So everything is based on hands. Exams I haven't decided, but exam 1 definitely is going to be no calculator. Exam 2 I haven't decided. Okay, but I will tell you. Expect some sort of have one digital device with your phone. Homework, I try to make it my turn bi-weekly because I made my homework shorter, like 2 questions every 2 weeks. So instead of you know, like making 3, you can get those out of your way. Try to be consistent on when it's due, when I release it. But if I wasn't, I would have it with you. All right, but expect every 2 weeks homework. The exam date for all of you on the 7th. So due to no change, but unless something happens, but it will be in person. Unless you have SLDS accommodation that you, if not, you have to send those soon so I can plan. All right. No late submission. Those of you that know me, you know that I mean it. You just get a 0. If you're on a date, this is going really good, and you're trying to submit afterwards, this is going really good. You know, so just send it before you go on a date. That is a big thing, you know. you're not crashing. Oh, teams. So your early assignments are going to be individual, even the program. The idea is some of you might not remember MATLAB very well. It happens all the time. I'll give you a month to remember MATLAB. I put some resources for you. Plotting, how to get input data. Sure, all those things. The few first assignments will be helping you to remember those things, to do them individually. Don't go online and find something because you're going to use those skills later. If you happen at some point look online, like consult with someone else's code, the best case scenario, might think we're cheating. You have to cite it. So I need to know that you're upfront and hey, I looked at this code before I read mine. Because the way you code, like not two people can code the same way, the same mentality, right? Same algorithm. I just need to know that you use this reference and that will be fine. But your code has to be original. Like you just have to say, oh, that's how we do it. Then forget about it. You start doing it yourself. So try to build this skill. At the end, you end like the final project is like this. To have a robotic arm, you have to model everything, links and joints and everything, reference frames. Joints are going to be different velocities. You have to find where the joint will end up and type a bunch of matrices, like Booleans, dynamic, plot the path. We're going to break this down. So if you don't work on this by yourself, the final project, promise you, will be disaster. I'll put you in teams for those bigger projects, right? At some point, I will send out some survey later on to team you up. But if you have someone or you found someone, you can communicate with me. I can put you in teams, all right? Because teamwork kind of works with the scheduling too. So I will give you that opportunity. Any questions on this part? Everyone's fixated listening to me. I love it. Use office hours. I haven't posted anything for office hours because I want to figure out week one first. I don't think you'll need office hours right now. You can always email me and ask for office hours for Meet. It could be on Zoom or in person, right? So feel free to do that. Same for Brad. He is a graduate student. I actually will let you introduce yourself. But he has to also study, right? But he can help you a lot. Give me feedback so I can help you better. Now you can introduce yourself.
Sure. Hi everyone, my name is Brett. Like Steve said, I am a graduate student, electrical engineering. So I'm pretty familiar with the course material. Like you said, I have to study too, but I try to study. So send me out my email. Yeah, I mean my office hours are already set. So and I can change it down or a majority of it, I suppose. It's gonna be Thursday and Friday. 10 to 12 p.m. Not like 10
a.m. to 12 p.m.
But yeah, that's pretty much all of you.
I will put my office hours. I will figure it out, but then we will revisit the office hours. If I see that it's not working for majority, it means that nobody comes to office hours. I will talk. If you wanted to change, we can change it. Okay. I haven't decided mine yet. He had to decide because there is a physical office that you can go to. What is the number? Okay, so he actually has a physical office, but he can also meet you on Zoom. If you're not comfortable, you're working, or you're in library, you don't want to walk, you can just Zoom in. All right. For the book, you can find online. You don't have to buy it. If you want to buy a book, buy this one. If you want to stay robotic, there are less topics in SPOM than in. So the other book is more. Has more topics and stuff, but I really like the way that the SPOM is teaching, and I kind of follow that. All right. So if you ever wanted to buy a book, this is the one you want to buy. But the topics of the class, things that we will talk about, will be from Lynch, and I will share his videos because some concept he explains it really good. I think like it's worth you watching 5 minutes of him and 15 minutes of me and just not understanding what's going on. All right. Okay, now it's time. Carmen Page. Let's go take a quick look at our comment page. So you can find everything in modules. Before we go there, so this is my Zoom information. This is office hours that I will enter here. I haven't decided, but also this is Brett's Zoom. Is this the same password? Okay. You can also see what's coming up here and your assignments. You go to modules. This is really important. So everything is weekly, based on weekly modules. We are in week 1. You will see all the lecture notes. So we're going to have Wednesday and Friday. So there are 2 of them. If it's Monday, Wednesday, Friday, it will be 3 things. If you click in on this one, you'll see the slides blank, annotated. So if there's annotation, I'm going to post that. I'll also post a recording here. If there are other things we talk or I want to get. So this way you have everything in one place. Now, there will be back in here, your assignment for this week, they're all listed here. They have deadline, due date that you can see. Sometimes they have an access date also. Because they haven't released, but it's there, so you know it's coming up. Some need passcode like this one. I will give you the passcode and I would not say it, I will write it. So you have to be in the classroom. All right, so this is my only way to bring it to the classroom. Then there are supplements. It could be, for example, linear algebra review. I think most of you can benefit. Sometimes will be practice problem solved here. So things that can help you. I'll put them here. And then this wrap-up fishbowl is an anonymous survey. 2 questions. You tell me if there was something muddy that you don't understand, or I did something that you, or I did something you like. But it's anonymous. Sometimes you don't know who you are, even though if you have the connection to that person. You know, this is your free pass to say anything. And I found it very useful when a student told me, hey, we didn't understand this topic. I think it's Monday. So my Monday lecture usually has a review covering all the problems that I didn't explain very well. So I can answer my lecture. All right. So take good advantage of that. I think I've done this last year, but so we're going like, let's say week 13 through all the weeks. Final lecture, I know. So what I'm doing this time is I'm putting all the lecture under lecture tab, right? But I don't want you to just go to that. Okay, I want the lecture for today. Your main source is the modules because it has everything. So the lecture tab doesn't have any of the supplements. It's just annotated lecture and blank lectures. Same for homework and exams. Like I already have homework 1 and PA 1, but you don't have access to it. This is not posted. This is not posted also. I mean, you don't have access to it. Exams, homework will be there with the solution. Once you have the solution, I'll post it here. So that's a quick access to find out, because I know in this exam, you really need to find something quickly, right? So these two hopefully will help you to access things better. If you find that the structure could be better, if there's something I'm not doing, you've seen someone else before, let me know. Put on the fishbowl. Okay, I can in my design and help you better. You can also access all the assignment here through this assignment tab and all the quizzes and surveys. So there are different access points for the same material. So you should not be confused where things are. If it ever happens, all right. Now, one of your assignment is discussion, introducing yourself. Please make sure you read what I'm asking you to do and post about all of those. All right. This is due on Sunday, so you don't have to do it right now, right away. But it's a good way of introducing yourself to everyone. All right. Let's see. Okay, any questions? Because now I can start talking about robotics. It's all logistics and everything that I wanted you to know. Any questions so far? We're all good? Okay. I'll give you a minute to take a breather, I'll talk about robotics in a bit. So, oh, before I start, those of you that are MPs and have trips, please pick 5, please do. Okay, so not too many. This should not happen in the scheduling, but it looks like it happened. I also teach trips in this semester, so I know that only the first few weeks is going to be lectures. After that, it's going to be meetings, right? So I either try to finish on time or early so you can leave, but I don't know where your meeting is. You can leave so you can get to your class or talk to your advisor that you might be late. Definitely talk to them that you might be late. But you have to have permission to leave early. So you'll be on time for class. But a lot of time I really finish at 3:55 because it's so hard to cut off the topic and then next class I have to start over again. Especially in the middle of the longer exam. All right. And you have the videos, you can always watch them. If you miss the code, you can always email me. All right. Okay. Do you guys hear me back there? Because I don't have my phone. Okay, because my throat is hurting, so you should hear me. Hopefully I can find my phone. Right. So I decided to a little bit talk about the symbolic representation of robots because from next class we're going to just see them. We don't see actual robots. I'll give you an idea what is. So robot manipulator are composed of links and joints. As humans, if you think of as robots, we are like pain robots. We have links on our limbs, and then we have joints, right? In all of our body. So we are actually, that's why humanoid are one type of robot because they're replicating humans, right? Now, we call the joints that bends like this or hinge revolute joint, and we show them with R. Joints that slide, we show them by P and they're prismatic. This is a sliding, right? Now, in human body, what kind of joints do we have? Someone else, come on, participate, yeah. Revolute. Can you think of prismatic joints in my body? Throat, what else? No, kneecap is not a joint. Well, it's sitting on top of, so it's sitting on top of a joint and moves because of that motion. Your big intestine pushes the waist, but human body usually like it's considered as all revolution. So yes. Huh? Tendon? No, there are no joints. We're talking about joints. Okay. So they're flexible parts. They're not joints. Now, the way we show them, revolute joints in 2 dimensions. You put 2 links and a circle, and you always show the direction of bending. Okay. Why? Why do we do that? Can I bend my elbow the other way? So if you wanted to model this robot, you have to set a constraint that it only rotates 180 degrees this way, correct? Or 90 degrees, depending on what is the point. So you always have to show the direction. In 2D, that's how you show it. Prismatic, you can show slides like that. In 3D, you'll see that a lot of times when you're working with 3D, things look confusing. That's why we will use this as the plate that is moving. Okay, and then this is the direction. So basically, this plane is bending over the other one. So if you look at this drawing from XYZ, let's say plane, you will see this. Okay, and then for prismatic, same thing. So you show this plate, and this plate or plane showing that we are moving in this direction. Now, if it was the arrow that has two sides, it can go either way. All right. Again, depending on your constraint, it can go one way or both ways. We are going to be using all of those, and we're going to model our robots with that. Now, so your first robot, this is called an articulated manipulator. The reason is that articulated is when you have all revolute joints, like human arm, for example, leg, then we say articulated or anthropomorphic, like human, like that resembles human. Now, there are a couple of things we need to know about when we this diagram of robot. First of all, how many joints do we have? How many limbs do we have? And where is the rotation? Like if it's clockwise, counterclockwise, so this arrow is important. We also have an axis that the joint is rotating about, so it's rotating the link. So let's look at my arm. So this joint is moving this link, right? So a joint always is moving a link. So you can't have a joint at the end of the chain. So what is this doing? So here my wrist is actually moving this part, which is the most important part, the grabber, the end effector, right? So this whole body, this whole arm is built so the end effector can perform its task, right? So every time you see a joint, there should be something connected to it, unless you know there was an end effector at the end. Sometimes for simplicity, we don't show the end effector. We just say, like, for example, the forearm, there is going to be something after. We cut on purpose, but we know something is connected. So when you have 6 degrees of freedom, we usually say, okay, let's just build the elbow and a wrist. So 3 and 3, let's make things simpler. But if, yes. No, no, because the joint, yeah, good question. It's not a bad question. Yeah. Wouldn't consider as, well, there was a joint there, right? But a joint has to move something. So if there's nothing to move, you would never, if this is a servo, move that servo because there is no goal. So this is an over design. So if you want to cut right below. Does that make sense? Because it's not going to do it, it's just maintenance. All right. So a joint always have to move another link or an end effector. All right. I will learn this, promise. I would not learn this live. I've done this before. Okay, so link I move. One thing before you get confused, there are two different way of naming. All right, and we will immediately something that is not following what I wrote. So first, how to call join. So that's the naming convention. This is join number 1, join number 2, join number 3. What is the type of each of these joins? Revolute. There are origins, right? Now, point I connect link I and I. So this is link 1, this is link 2, this is link 3. There will be something connected there, right? Now, and your base is always 0 to start. So you name your base 0. So that would be, you always put your frame 0 there. Now, ZI axis, either joints have an axis. They either rotate around it or translate along it. Now here it says ZI axis of rotation of revolute or axis of translation for prismatic joints. Now you see that Z0 here, right? Let me read that. So this is Z0 that's connected to joint 1. This is where naming convention comes in. So you'll see this later. So your first joint, so you can call this Z1, Z2. But we will see there is a naming convention that I borrowed this picture from that you could call that first one Z0. Right? So for now, don't get confused. So since I borrowed this, I didn't think about it. I was reviewing my slide and I realized that this might not follow what I wrote. So it was Z0. I changed it once. Now your first joint is rotating around Z1, your second one around Z2, and your third one around Z3, right? So for now, every joint has its own Z-axis, and you see that our Z-axis are moving. We are going to learn how to define them and how to define matrices between them, so we always know how Z1 and Z2 are related, and therefore rotation matrices. And you're going to use that. So this course, you need linear algebra in terms of you're going to be doing a lot of matrix multiplication. There's going to be a lot of vector algebra. I trust that you will know when to pre-multiply, when to post-multiply. So that appendix I put there is to help you to refresh your mind. And next class, I'm actually going to go over them, but not in depth, just to review and help you where to study. So be ready for doing a lot of simple math. So if you thought you wasted your time, you didn't. You're going to use all of those in this course, a lot of math. But they're not going to be like super duper difficult. We'll do differential equation at some point. Okay, so when you are, so this type of robot, this is an articulate manipulator. How do we describe this configuration? We call it configuration. You look at the joints and identify what kind they are, and you call your configuration with the joints type, because you know there's going to be links in between them. So the links are there. So this is an R robot. All right. So you would know if I define variables, it's going to be theta 1, theta 2, theta 3. Could I call it, I don't know, something else other than theta? Yes, you can call that variable anything, but theta is always reserved for angles. Why we're using angles? Because we're rotating. So this is 90 degrees, or what, however radian, pi over 2, right? So we reserve theta for angles. Now, what if we had prismatic? So first of all, tell me, yes. Huh? Here is, so that's your joint variable. So you'll see better here what it is. So you create a vector, call it joint variable, and then you put your variable in there. So my Q has 3 elements that shows I have 3 joint variables, theta 1, theta 2, theta 3. Now, what type of joints do you have here? So you raise a hand. Oh no, who doesn't know? Okay. Revolute and so there's one Revolute. No. Who else wants to correct M? Okay. Do you agree with him? To Revolute. So here, theta 1, theta 2, and for prismatic, we show them with D. Just because we reserve distance traveled by D. So why did I say D1? So when I create my Q vector, the joint variables, I'm going to say I have theta 1, theta 2, D3. There's my third joint, I, right? Now, this is just convention to help someone else when they're looking at it to understand this third one is a prismatic joint. Yes. Oh, thank you. You had a question? Yes. Yeah, so you decide which one you're going to call first. Yes. We're going to have, actually, a good question. Look at your shoulder, right? Yes. How am I rotating this? In all directions, right? So this must be a revolute joint, but this is moving more than one direction. This is actually made of 3 revolutes. So we're going to break this down to 3 revolute and decide which one is going to be 1, 2, 3, and we stick to it. We put reference frame on it. They're all going to have the same rotation matrix because they're all moving this together. It's a great question. So this robot is RRP, revolute prismatic. Because if you had it RPR, it would have been a different robot, different manipulator arm. speaking of that, you could also have still RRP with different configuration. The direction of, so look at Z1, Z2, Z3, let me fix that. So you see the direction of rotation here, and then what this robot is capable of. This robot is good for shooting down pointing lasers. It rotates, moves, and can have an effect to do anything. So these two are kind of shoulder. But if you are this robot, it's a different capability. The direction of the z-axes are different. They're both pointed upward. Z1, Z2. This I'm going to call Z3 because I'm trying to match for now with this one. So if you see these two are parallel, these two were coinciding with each other. So even that is going to affect how the end effector is going to move. So we are going to be able to show that in our matrix. Yes. Yeah, so the Q is just saying what are the variables. So you're kind of defining the configuration, but configuration itself is not enough. You have to give a direct. What is a vector? Anybody knows what a vector is? How do we define vector? So it has a scalar value and it has a direction, right? The same things we are using here. So we're going to have a direction and value for them. So the direction of the z-axis, that's important. We only show one because we can know what the other two are from right hand goal. We only show the axis. And then the q's are the scalar value, like the variable. So it doesn't tell you the direction on this one. All right. Now, what is this? How many joint variables? Tell me what is the q vector here? The joint variable. So what's q? So what is it? Exactly. Right? And we also know the axis. So this is the axis of rotation. This is the axis of translation. And this is on this side. We get to play with all of this. So yes. Yes, you have to. Yes. Because then at sometimes there is a distance. So right now, these two are actually, when there is no distance between them, they're on top of each other. So the question you asked. So this actually, if you look at here, this rotation and translation are one. No, it's the direction of the joint moving, either rotating or translating. Z is just a vector. So Z is the z-axis of your reference frame. So reference frame is three orthogonal vectors together, right? We just show that because we know the X and Y. If I tell you where Z is, you can be able to find the other two. We will discuss that when we get to kinematics. So this is more of giving you an idea of what you will see. So defining all of those has a technique. We're going to work on that. There are actually different techniques too, how to define your z-axis. All of these are convention. You might go and read a paper right now that says something different. Like, what the hell was she talking about? There are different conventions. This is something that you most all the time see. All right. So if you open your book, you will see it. So that's why I decided to introduce that to you. But we're gonna at least go over two different conventions. All right. And this one is a Cartesian manipulator. You can see it can be used for picking, sorting, or printing. You have seen your printer, only move prismatic and X, Y, Z axes, right? They don't rotate. So, and you see that there is the basis here. This is over here. So we're not discussing that right now. This is the Z axis. And here we can have an indicator that does whatever. We don't discuss that right now. So if I wanted to Q for this part, it would have been P1, P2, P3. This is a very simple robot, something that's very easy. We can model this. And so we will start with something simple and then make it more complicated. Actually, the complication, this is the most simple, RRR is the most complicated. All right. Okay. So today, first thing is that be excited. Okay, if you're not excited, don't. You have a bunch of things to do. I need to give you the code for this. Someone left, didn't get the code, but they can email me, hopefully, remember. So, do you all see the code? Can you? 2021. Yes, A has to be capital. Yeah. Don't forget to do your assignments, and I'll see you on Friday.